All right. So how do we solve this? In fact, you can just raise your hand and tell me the answer, or even shout it. 1. How many of you got 1? 1 person. 2 people. That's it? So this is what I would like you to develop very good intuition about. Why is it immediately 1? How do you visualize it?
As the angle gets smaller than the difference between them.
Precisely. You can prove it. You can prove it rigorously, or you can just observe that this arc and this distance are pretty much very similar. The same idea that we used when we established limits for sine. Sine of theta over theta. Similar idea. That's not a rigorous argument, but it's a good argument. Notice that as theta goes to 0, d and s are becoming alike. Hence, limit as theta goes to 0 plus of s divided by d is simply 1. If you want, you can do something like this. So this is the angle theta, and I cut it in half. And I observe that this is a right angle. So I can observe here that d divided by 2 is equal to r sine of theta divided by 2. Okay? And that means that d is equal to 2r sine theta divided by 2. What is s in terms of theta? We're using radian measure. What's s in terms of theta?
Isn't it theta?
It would be theta if we measure, you see here, the fact that we label this as r means that we measure the circle not in terms of the radius. We're not using that natural measurement. We're measuring the circle using some other units. So in those units, the length of radius is not 1. The length of radius is some number r.
Pi over 4?
We don't know about pi. There is a theta here.
Pi over theta over.
So s is theta times r.
Theta over 3.
Theta times r. Or r times theta. Why is that so? Because I need to recapture the idea that, that this angle, if I measure it in radians, it will be how many times does s accommodate the radius r? Okay, that would be the angle. So s divided by r will give you would give you the angle theta. That means that s is equal to r times theta. So using calculation, you can do something like this. You can say that this is limit where theta goes to 0 plus of s, which is r theta, divided by d, which is 2 r sine of theta divided by 2. Okay? Then what we have is that this r crosses out. So this would be theta divided by 2 sine of theta divided by 2. Now, we learned how to solve this. And this will be the same as 2 theta over 2. Remember this idea that sine of theta over 2, if the angle is very small, is the same as theta over 2. Right? In the limit. They're not the same, but in the limit that will be so. So what we have is now that this limit is where theta goes to 0 plus theta divided by theta, or simply 1. Long way to do it. So very good if you see it right away.